Dear students, welcome to SCPS online live class 8 English version. This is your Kamrul sir. Alhamdulillah, I am fine. I hope you are also fine by the grace of Almighty Allah. Dear students, today we will discuss exercise 10.2 and 10.2 you will get some problems. Today we will discuss problem number 1 and problem number 5. These two questions, they are most important on exercise 10.2. Now dear students, we can start. Problem number 1. Look, what is said the problem number 1? If two equal chords of a circle, that means two equal chords intersect within the circle, they will intersect within the circle, that means it will be internal of a circle. Prove that. Now we have to prove that the line segments of one chord are equal to corresponding segments of the other chord. That means, look, suppose this is our circle and this is the center O. Now look, suppose this AB and suppose this is another chord CD and these two chords are equal. Look, they equal, these two chords are equal. So here AB and CD are equal. Now they are intersect within the circle. Now which point? Suppose this is E. Now we have to prove that, line segments of one chord, line segment, look, there are two line segments. This is CE and this is ED. There are two line segments, AE and BE. Now we have to prove that they are corresponding segments. That means CE and BE corresponding, ED and AE, they are corresponding. Now we have to prove that these corresponding segments, they are equal. So we have to prove that AE equal ED and CE equal BE. This is our target. So dear students, now write problem number 1, particular enunciation. You have to write the full form, particular enunciation. Let AB and CD are two equal chords of a circle with center O. So here AB and CD are two equal chords of a circle with center O. They that means two equal chords, they intersect at the point E. Now these two chords, they are intersect at the point E. Now it is required to prove that. Now it is required to prove that. That means we have to prove that AE equal ED and BE equal CE. So these two they are corresponding segments. So between these two chords, they are corresponding segment AE and ED and B and C. Now we have to prove that these corresponding line segments, they are equal. So this is our particular enunciation. Now we need construction. So now write construction. We draw OM perpendicular AB. OM, suppose this is OM. This OM perpendicular to AB and ON perpendicular CD, and draw ON, this one perpendicular CD. and join O comma E. Now join O and E. So join O comma E. Join O comma E. So this is our construction part, dear students. So particular enunciation, that means we have to explain the question according your sentence. This is our particular enunciation, and this is our necessary thing to prove it is necessary. This is our construction. Now we will go to our proof part. Now dear students, look, in proof part, at first look, here OM and ON, suppose this is OM and ON, they are perpendicular. So in our theorem number 1, we know when this is perpendicular, so this M, it will be midpoint, and this N, it will be also midpoint for CD. So we can write, since OM perpendicular AB, OM perpendicular AB and ON perpendicular CD, so M and N, they are midpoint of the chord. They are midpoint of the chord. So we can write, if they are midpoint, so we can write, therefore AM equal half AB. So this AM, it will be the half of AB because this is the midpoint, and also ND, this will be the half of CD. Clear? Because we know when we draw perpendicular, then it will be midpoint. So it will be, AM will be half of AB and ND will be half of CD. Now dear student, look, our question said that these two chords, they are equal. So now AB equals CD. Why? They are given. Question said that they are given. So now we can write half of AB, it will be half of CD. If AB equals CD, so half of AB, it will be half of CD. Now for half of AB, we can write AM, and half of CD, we can write ND. So now we can say AM and ND. That means this part and this part, they are equal. But look, dear student, we have to prove that AE equal ED. So our sum part is done. Now we need another two one. Look, this one and this one, ME and EN. Now if we can see that this and this are equal, then we can write this part and this part, they will be equal. So now dear students, there are two triangles. So according to the congruent method, comparing. Now look, in triangle MOE and triangle NOE, comparing these two triangles, we can see that OM equal ON. Why? Because these two chords are equal, and we know when chords are equal, their distance from center, it will be equal. So OM equal ON. And now we can write, this is 90 degree, this is 90 degree. So if we look this and this hypotenuse, it's enough. So we can write hypotenuse OE is common side. Here hypotenuse OE, they are common side. So we can write OE equal OE like this. So hypotenuse OE, this is a common side. So we can say these two triangles are congruent. Therefore, triangle MOE congruent triangle NOE. Now dear students, these two triangles are congruent. So we can write ME equal EN. So ME, this ME and this EN, both are equal. Now dear students, look, this one and this one, Look, these two equation. Now if we add these two equation, therefore m plus me equal nd plus en. That means if we add these two equation, left hand side with left hand side, right hand side with right hand side. Now look, m plus me, look, m plus me, so it will be ae, and nd plus en, so it will be ed or d, both are same, so we can say ae equal ed. Look dear students, this is our required part, so we can say they are proved. Now another one, this one and this one, we have to prove them. Now dear students, now we can write again, look, again AB equal CD. Look, AB equal CD. This is our given part. Now if we subtract this one from AB equal CD, that means we can write AB minus AE, CD minus ED. Now dear students, look, AB minus AE, this is AB, and if we subtract AE, AB, if we subtract AE, so it will be BE. So it will be B, and CD, that means whole chord, and if we subtract ED, so it will be CE. Now dear students, so this one and this one, this is our required part, so we can say they are proved. Very simple dear students. Okay, now we will go to our problem number 5. Look, problem number 5 said that prove that between the two chords, the larger one is nearer to the center than the smaller one. That means suppose you have a two chord, one chord is larger than another. Now the larger chord, it will be nearer to center. We have to prove that the larger chord is nearer to the center. Okay, now dear students, at first we can draw our figure. Suppose this is a circle. Suppose this is a chord AB, and suppose this is a chord CD. Look, here AB is greater. You can draw streak, direct streak you can draw, or you can draw as a not a streak. Any angle you can draw, not problem. Now suppose there are two chords AB and CD. So here AB is the greater than CD. Now we have to prove that this AB is nearer to center. Now what is the distance? Means perpendicular. Suppose this is our perpendicular. Suppose this is OE, and this is our perpendicular. Suppose this is F. Now we have to prove that OE, this is small than OF. We have to prove that this. That means OE less than OF. So OE less than, that means OE small. So this is nearer to the center. That means distance, less distance. Clear dear students? So this is our required part. Now we can write our particular enunciation at first. Particular enunciation, problem number 5. Let AB and CD are two chords of a circle with center O, where AB greater than CD. Suppose here AB is greater than CD. OE and OF are the perpendicular distance. Perpendicular distance from the center O. Here OE and OF are the perpendicular distance from the center O on AB and CD respectively. So we can say OE, this is the perpendicular on AB, and OF, this is the perpendicular on CD. Now it is required to prove that OE, this is smaller than OF. That means OE smaller than OF. We have to prove that this one. So dear students, this is our particular enunciation. Now we need a construction. If we join OA and OC, then we will get two right angle triangle. So we need construction. So dear students, now construction. We join OA and OC. Now we join, look, OA and OC. Now dear student, look, this is a right angle triangle and this is also a right angle triangle. These two right angle triangle, their size is different, clear, because this is greater and this is smaller. Now dear students, if we apply our Pythagoras theorem, clear, then we will get our final destination. Now dear students, now we can go to our proof. Now proof. Dear students, look, here OE and OF, they are perpendicular, so we can say that AE, it will be half of AB, and CF, it will be half of CD. Similar case. Okay, now since OE perpendicular AB and OF perpendicular to CD. Suppose this is perpendicular AB and this is perpendicular to CD. Now therefore we can write AE, this is our half of AB, AE, and CF, this is our half of CD. Clear dear student? Because we know when we draw perpendicular it will be midpoint. So AE, this is half of AB, and CF, this is half of CD. Now our question said that AB greater than CD. It is our given part. Our question said that AB greater than CD. Therefore half of AB, so it will be greater than half of CD. So half of AB, that means AE, and half of CD, that means CF. So we can say that now AE greater than CF, because half of AB also greater than half of CD, and half of AB, that means AE, half of CD, that means CF. So we can say AE also greater than CF. Okay dear students, now we can write from these two triangles. Dear students, from these two right angle triangle, look, in triangle AOE, in right angle triangle AOE, we can write OA square equal OE square plus AE square. How? Dear students, we know according to the Pythagoras theorem, the square of other two sides, the sum of square of other two sides, this is equal to the square of hypotenuse. So we can say OA square equal OE square plus AE square. Similarly in triangle COF, we can write OC square, this is OF square plus CF square. Now dear students, here OA equal OC. Look, here OA equal OC. Why? Because they are radius of same circle. So here OA and OC will be same. OA if 5 cm, then OC also will be 5 cm because they are radius of the same circle. So we can write OA equal OC. Or OA square, it will be OC square. If we square both sides, no problem. Now dear students, OA square, we can write this one. OA square plus A square. And for OC square, we can write OF square plus CF square. Now dear students, now we write a most important sentence. Look, dear students, if we write OE square plus A square, that means 100% same things, left hand side. Now OF square plus CF square, if replacing CF square, if we write A square, now what will be our problem? Look dear students, CF and A, we know AE, this is greater than CF. Look dear students, we know AE greater than CF. Look, this is CF square and this is A square. So A square, it will be greater than CF square. That means the value of A square, it will be greater than CF square. Now if we write A square for CF square, so our right part, it will be greater. Look, this left part and right part, they are equal. But if we write A square for CF square, since A is greater, so our right part, now from then the left hand side, our right hand side, it will be greater. So we can say this is greater side. Now dear students, if we omit, look, A square and A square, if we omit this two one, so now we can write OE square less than OF square. Now if we omit the square, that means if we both sides we can get the square root, then we will get OE less than OF. So our required part, OE less than OF. So we can write proved. Very simple dear students, and these two maths most important, not only exercise 10.2 but whole chapter, that means circle, these two maths most important one. Now dear students, problem number 2, 3, 4, they are most easiest problem in exercise 10.2, and problem number 6, it will be a creative question, and the C part of the question, it will be our problem number 1, that is already solved, and B part, it will be our theorem number 2 or 3. So we can say our problem number 6 also solved, and 2, 3, 4 very simple. If you read, you will be able to solve it. Okay dear students, thank you very much. No more today.